Hi, it's Wray Schelin from ProShaper Sheet Metal in Charlton, Massachusetts, and tonight we're going to actually be doing some metal work. Part 3, Jaguar E-type aluminum nose. So we have the blank. We showed you the whole process of how to make that flexible shape pattern blank. We're making this right side half of the front nose section. So what we need now is how big a piece of metal do we need. So what I usually do is just take this over, I clip it onto the piece of metal and I cut it. But on this one I'm going to do a little bit something different. I'm going to show you the process of taking the pattern, you squash it out like this. Now remember we added extra material on here, so it says add 1.5 inches. So even though it says add 1.5 inches, I'm going to add more. I always add more. So I'm going to take and make some lines on this piece of paper. Alright, so I'm going to mark the corners here a little bit so I can put it back on the same spot. And this one says add 1/2 inch. I'm just going to go about 1 inch or a little bit more. I got a nice line there. This one says add 1/2 inch. These are both weld lines. 1/2 inch is more than enough, but I'm actually adding a little extra here. So I got my line there, and this isn't a straight line, so I'm going to have to freeform it in. Here, this is actually where it gets cut off. I'm going to add probably initially just a little bit more here, 3/4 inch or so. So there's a nice margin there. This has a flange on it, and this one has a flange. So this one says add 1.5 inches. So I'm going to bring it up here, and I'm going to make sure I got enough there. Nice line there. This is where the joggle is. It says add 1.8 inches. I'm going to go a little bit more than 1.8 inches right there. And that's my other flange area. So now I have a well-defined blank. I can use this blank piece of paper also for the other side. So it's a valid piece. And if you're making more than one, now you have that stage of the operation all done. So it's just a matter of cutting it out. Once you try cordless paper shears, you'll never use scissors again. So there's our blank, and we can identify this. We can call this E-type nose. Front section. And it's actually the upper. (1962). So there's our blank. Next step is we're going to use that blank to cut our piece of aluminum. Alright, this is the beauty of this craft, is this stock rack. What you're looking at is, it's a nursery for any car you want. There's a Rolls Royce in here, there's a Duesenberg, there's a Packard, there's a Ferrari. Whatever you want, it's possible. It starts out like this, and it ends up like whatever you want to dream. Every time, and I tell this to all my students, every time you pull a piece of a metal out of a metal rack, you pull it out, grab a micrometer, and you measure it. And I'm looking for 63 thousandths, 3003 aluminum. I only have 3003, so I know that's 3003. Oftentimes they're inked, and it does say 3003 on it. So I'm at 063. You always want to measure here. If you measure on the edge, sometimes the measurement can be off a little bit. This one's actually right on the money. It's 63, but oftentimes the edge is a little bit thinner, a thousandth or so. So usually these are 4x8 sheets, and if you pull them out, it's very difficult for one person to handle a 4x8 sheet and put it into the shear. So I use this little system. I use a 2x4. Take that 2x4. This sheet's already been cut, so it's not going to work as well. But if you have a full 4x8 sheet, now what that 2x4 does is it allows you room for the shear down below. So we're going to take the blank. We'll put the blank like this, and if I go like this with my finger, I need 2 of these pieces for both sides. That's going to be a little tight if I go that way. So I'm going to cut this one this way here. So I've got my marker, and I'm going to cut this a little bit wide right now. There's my point here. I'm going to give myself a little room there. I got plenty of room to make the second one over there this way. So I'm going to go straight down like that. This piece is big enough or small enough that I could bring it over to my jump shear really easy, but I just want to show you this process. And again, a lot of these videos are meant to get the students acclimated to my systems before they come to my class. So everybody has their own ways of doing things. I've tried many ways, and I like this system the best. You put, especially with aluminum, you put a little WD-40 on the blade, makes it work a lot nicer. I used to use the corded shears. That's a Harbor Freight, inexpensive when they work really good. I use the cordless ones exclusively almost now. I hardly even use the hand shears anymore because these will cut a really nice, clean, straight line. Curved line, no problem. So my cut here is going to be straight down. You can grab this right here. You don't have a cord in the way. I got my little tick mark there. So that's the job of the 2x4, to give me room so that I can pop that off at the end. Otherwise you hit the floor and it's not cut all the way through. So the whole key of using these shears is as you're cutting it, you want to separate them a little bit. If you keep them tight together, it will bind on you. If you move it apart too much, it'll bind. It's just enough. So then it allows you to get your arm in there, and you can go all the way down. You can actually reach the floor no problem, especially if you have it up on the 2x4. So now the next step is to cut this down a little bit more. This is my cutting table here. I put 2x4s on it and make sure the 2x4s aren't dusty. A lot of times the tables will get a lot of grit on them and stuff. If you put the metal on them, immediately you have a whole bunch of scratches on it. Aluminum is sacred. I don't like to scratch the aluminum. So put them on the 2x4s. I don't try to drag them or anything. And we'll get our blank. Blank is going over here. We got plenty of room for the second one. I'll put this right on the edges over here. Right like that. I got my marker. And then I'm just going to do a perimeter mark here. Alright, so there's my blank. I'm going to save my paper. Well, I could actually mark the second one. I wanted to mark the second one. Now, could you make this piece in one piece? Oh yes, not a problem. I like to make pieces in bite-sized pieces, bite sizes, smaller sizes, especially with the students. The more you bite off of a piece, the more DNA you have to absorb and fit to, and plus the panel gets unwieldy as far as the physical limitations of your arms and stuff. So these are good ones, good sizes. That's a very easy weld. If you made it bigger, I call it the 2 poison pills. The first poison pill would be you have to do the welding if you make it smaller. If you make it full size, then you have the poison pill of trying to capture all that DNA of the surface information. So both ways work perfectly. Whatever suits your fancy works fine. So if you can do it in one piece, go for it. So now I want to cut it in the jump shear, so I'll go to the jump shear. I'll just rough cut this out with the jump shear, and then we'll detail it out with the cordless shear. So those are all the straight cuts. 3 straight cuts and then 3 curved cuts. Alright, so now we're going to use the cordless shear just to trim this final stuff off. We're going to be cutting these probably 2 or 3 times. One of my pet peeves at the class is after you cut something off, don't let it just sit on the floor. We'll put it here for now, but it's going to go into the scrap bin. So we rotate this around, and we always have the edge cantilevered. Now, it's best to approach this from this direction here. What that does is you can see that the waste piece is going down. If you go in this way, the waste piece tends to go up. They have a shield here to protect your fingers, but it kind of fouls there. It needs that clearance to cut nicely. So you're always attacking it from the perspective of making sure that the waste piece goes down. And I just broke the rule right there, but I was just clipping that off. Alright, so we're going to just rotate it around. We're cantilevering it off the bench. Plenty of room for the tool. So there's piece number 1. Now if this was steel sheet, all steel sheet is coated with a protective oil coating. And after you cut them, actually before you cut them, so it doesn't mess up the flexible shape patterns and your blank pattern and stuff, you lacquer thinner them or acetone them to get all that oil off. The aluminum, not so much. I get a little bit of WD-40 that dripped on them, so I'll wipe them down a little bit, but they're generally pretty clean. So there's our 2 blanks. If we had all the flexible shape patterns for the entire bonnet done, and we wanted to be in a production mode, and we had all these blanks made, be left and right, then we could cut all the metal probably in a half an hour, and we'd have the entire amount of metal that would be needed to make the whole nose probably all cut in about a half an hour or so. Now these cuts are just what I call gross cuts. This is probably going to get trimmed 2 or 3 times before we're finished. So now the next step is, where do we go from here? We're going to go over to the bench and we'll talk about that. Alright, so we have our flexible shape pattern, we have our first blank, and I've got the flexible shape pattern sitting up tall, means air is under it, and I'll take a straight edge like that and put it on top of that hill. And my general rule of thumb is if there's 3 inches of space between that straight edge when it's parallel to the bench, you definitely should do some shrinking. This one I don't think qualifies, but it's really close to 3 inches, so I'm going to shrink. Where am I going to shrink? Well, the mountain is all right here. That's where most of the work has to take place. Less and less as you get towards the back. We inflate it totally. And we've taken tape and taped a flexible shape pattern completely down on a piece of flat blank and put a couple pounds of air pressure and blew it up like a balloon. And that shows you how it tapers off to the edge perfectly. So we're gonna do a little shrinking, and this is 3003 063 aluminum. Do we need to anneal it? No, we don't have to, but annealing it will make this a little bit easier. Generally, I do not anneal. Probably 90% of the time I will not anneal aluminum. In this case here, because it's a little knotty right in here, it'll make it a lot easier if we do the shrinking with the annealing, which will allow also the arrangement to happen a lot easier. Where do we need to shrink into? Well, this is the top of the mountain right here. So we're going to mark that. First thing we're going to do is actually get a perimeter on this thing. We're going to knock it down a little bit. We'll do a perimeter all the way around it. I'm off on my line here a little bit. Let's see. That would be better there. This is real preliminary. It's not super important right now, but gives me a somewhat of an idea. So there's my perimeter marking, and this is the top of the mountain right here. So I'm going to shrink into about here, and I need to anneal that. That'll make it work a lot easier. So first step is annealing the aluminum. I don't have to anneal the whole panel. The rest of the panel is nothing. This will get a little stiffened up as we work it anyways. And it has a lot of shape in that spot right there, so it'll be really super strong. So first thing we're going to do is anneal that section right there. So I'm going to show the annealing process. Okay, I got a couple pieces of the 063 that we just cut off. And this is 063 H14, which is half hard. And if you take your 2 thumbs and you go on a corner, hard as you can push, you can't bend it unless you got stronger thumbs than I do. My thumbs aren't that strong, but I can't bend it. So using these 2 pieces, I'll show you some of the mistakes. So light the cutting torch up. You bring it back till it starts to smoke. You put a little carbon on here, soot them up. Add your oxygen, neutral flame. Now burn that soot off. Aluminum, brass, copper, bronze, and I think that's about it in my knowledge base. Those are the pretty much all the metals that I will use, other than steel, they all will anneal pretty easy. Copper, brass, and bronze you have to bring to a red heat. This here you just burn the carbon off. So we burn that little section off, we'll shut the torch off, and we'll cool that down with a hose and see if we did anything. So now I take my same two thumbs, and look at that, now I can bend that over. So that's the proof that you got it up to temperature. It's 750 degrees, I believe, is the annealing temperature for aluminum. So now that is officially annealed. You should test it every time. You can see how that's bending really easy here. If I try to bend it over here, not so easy to bend it. So that is the proper way to do it. Now I'll show you some of the mistakes you can make while you're annealing. If you put the soot on too heavy, sometimes that can cause a little bit of a problem. So I'm putting a real heavy-duty soot coating on here. You got it too hot. I'm purposely going to make mistakes on this one. So right now I'm probably a little too hot. Being too hot can be having too much oxygen into the mix, or being too close and not moving fast enough. So it's very difficult sometimes to have a conversation. You have a friend over and he's trying to have a conversation with you, and you're trying to anneal and you're not paying attention. Stuff like this can happen. Now, I don't know if you saw the little color change, but that's what I call a scorch. That's not fatal, but it's not a good thing. Try not to scorch it. So you got to keep moving. You got to be a good distance away. If you got a heavy coating, you got to spend a lot more time, and you got to be really careful you don't do the scorches. Worse than a scorch is that. See, now you're getting melting. See how that's melting right there? So you got to be very careful. You have a big panel and you're trying to anneal something and you ruin the panel because you've overdone it. So that's what I was trying to show here, is you got to be careful. Take your time and you'll get the results you want. There is the scorch, which isn't fatal. And there is the melting. That's not good. That one's not too bad. You probably could rearrange it back again and probably it'll be okay, but it only takes another second or so and then you have a little blob on the floor. So you got to be very careful when you're annealing that you don't get too hot. You got to hit the Goldilocks, that's 750 degrees. If you're too cold, you don't get the annealing. If you're too hot, you make the mistakes. So you got to be in that nice zone. Of course, the edges are going to heat up a lot faster, so you got to be careful on the edges. The panel will jump around on you a little bit. It's not an issue at all. And it's a pretty heavy coat that I put on here, so I got to be careful. If you put a light coat of the soot on, you can do it in 2 rounds. Just do it twice, and that'll ensure that you really got it annealed good. This was actually a pretty heavy coat. You see it's not coming off that fast. So. Of course, aluminum transfers heat really fast, so it's heating the rest of the panel as well. I think that'll do it. That was a pretty heavy coat. Now, do you have to put the water on it? No. The water is not magic. All the water does is it saves you about 10-15 minutes for that to air cool to room temperature. So now the test is the thumb test to see if we've actually done anything. We had to get it to 750 to get the full release. No, that was not successful. Didn't anneal. So there's an example. I went through the motions and I didn't get the result. So we're going to wipe it down and we're going to soot it again. Okay, so I did the first coat and it was a heavy coat. I was cautious. I have to bend over a lot. My back was killing me. So now I've got a chair. I'm going to have a lot more control over it. So I'm going to soot it up again. I wiped it down. And this is not uncommon. It's happened a lot to me that you won't get the full anneal on one shot. That's why sometimes it's a good thing to advocate for 2 anneals. I got a lot more control now because I'm not killing my back bending over. So what I'm going to do now is I'm just going to do it incrementally here and go right up the whole amount here. Burning it right off. So I had a bunch of magic marker marks on there also, and they were still there from the first annealing. And generally magic marker can be used as an indicator of heat also. So this time I made sure that the magic marker burnt off as I was doing the burning off of the acetylene soot. So now we've got that to that stage. All right, now let's see if we got the desired result. All the magic marker burnt off, even the factory inking indicating it was 3003. Now I take my thumbs, oh look at that, now I've got some malleable aluminum. So we're all set. So the lesson there is sometimes it takes 2 times. The magic marker is a really good indicator. Maybe a combination of taking the magic marker, making a zigzag line through it, put the acetylene soot on it, and you burn the acetylene soot off, but make sure that you take the magic marker too at the same time, and you'll get the result you're desiring. Alright, so we're all annealed now. We've got the flexible shape pattern over here again. I'm going to mark where that top of the mountain is right here. So I'm going to put that line in again here. And I'm going to anneal, not anneal, I'm going to shrink into here like this. Now I need most of my shrinks over here. These are probably a little aggressive. So I'm going to do that like that. This is where it needs the most shrinking right here. Less as you come this way. So that's the neutral zone, the top of the mountain. So most of the shrinking is going to take place here, less and less and less as you get to the top of the mountain. Now this is my gathering tool I made. Eventually I probably will sell these dies. I prefer this method. It's very controllable. I don't use tucking tools. The reason for tucking tools that I wouldn't use them is as they come in, they always leave a little divot right at the end here. So I have my flexible shape pattern, real convenient to me, and I'm going to do the first gather right here. Now I want this to go down. It's got a curl going on here, so I'm going to curl this way a little bit first. Maybe I'll do this one here. Now using this tool, you want to get it right at the very edge first, and you want to make sure that these go down. So I'm forcing it a little bit down like that. So now I'm going to just bite into it there and bite into here. That's going up. I don't want that going up, so I'm going to force that down here. That's what I want to see right there. Now I have a trump with thumbnail dies. I hardly ever use it. I like doing the shrinking this way. I think it's more accessible to more people. One of the barriers to being able to develop these skill sets is everybody thinks you need all this very expensive equipment. This is a pretty inexpensive piece of equipment. You don't need one as elaborate as this. Is a really nice arbor press, but you can do it with a $50 arbor press, a used arbor press. And what this does is just gather up the metal. You'll see it. Because of the annealing, it had this direction in the metal that wasn't right. You want this side and this side to go down when you bite in here. So I'm going to just take little bite-sized bites coming into the line, the top of the mountain line. Now this allows you for deep shrinking, and that's one of the arguments that the thumbnail dies guys use, is that when you have a Polmax or any machine that will run the thumbnail dies, you can go really deep. Generally you don't need to go too deep to get the proper amount of shrinking. And this is very controllable. So there we go. We got that in there like that, that like that. And these I don't have to go as deep. I'm not going to go as much on this one. If you over shrink, it's very easy to stretch it out again. So that's all gathered, and now when I put the flexible shape pattern on it, it'll show that now I've created all this. See, this lays down really nice now. So I've created a lot of the area change that I want, but we're only going to be able to capture some of that. Generally with each one of these gathers, which literally just take minutes to do when you're not explaining it, of course, you can lose about a 1/16 of an inch or more in the linear length here, and that's what we're doing, reducing this linear length on this edge here. When you do that, it kind of puckers up the center here. So now we've got the gathers in, and as you can see on the other side, now what we got to do is crush these down. So we're going to go over to the shrinking facilitator, and I'll explain why the shrinking facilitator is a more user-friendly tool than, say, a stump. So we'll go to that'll be the next step. All right, so what we have here is the traditional stump, and this is one of my shrinking facilitators. And I prefer to use the shrinking facilitator. The shrinking facilitator is just made out of regular construction lumber. I have a lot of students from all over the world, and they come in and I'll say, okay, you can use a stump. And they say, first thing they say is, guess what? We don't have any hardwood in our country or in our territory or whatever, so they can't get it. But you can get common construction lumber. In this case here, I think it's 2x10s or 2x8s. You make it by band sawing instead of chain sawing out the hollow. I have a video on my website that will show you the whole thing. It's an hour-long video how to make one of these shrinking facilitators. I had somebody comment that, well, yeah, you got like 6 shrinking facilitators in your shop. Nobody has room for 6. This is a generic one. You can do a ton in this one. It's a lot more user-friendly than using a small stump like this. Can you do it in the stump? Yeah, you can do it in the stump. But when you're doing it in this stump here, it's a little smaller here. This would actually work pretty good, to tell you the truth, right there. But I think you can get a lot better results here. Now, generally when you're doing this, it's going to megaphone back at you, so you want to put headphones on or muffs. So I'm going to go get a pair of muffs. So now I'm all set. I got muffs on. I got a glove to protect my hand. I generally hold the panel with one hand. Oftentimes I'll sit down because I hate having to bend over all the time. My back hurts, so sitting down works really well. So what you're going to do here is you hit the tail of this. When you're knocking these gathers down, the angle is like this. And if you don't keep that angle like that, what will happen is it escapes like this. You go through all the work and you don't get any gain. What you want to happen is this. The metal pushes into itself. And when that happens, this ridge here becomes a hard spine. That's where the collision of the metal happens. So let's hit one here. This is the important one right here. I use these mallets. We make these mallets. These have Delrin heads in them. I like the Delrin because it doesn't mark the metal up as much as a steel hammer or a steel mallet. I do use steel mallets sometimes on very stubborn pieces of metal or thicker pieces of metal, but for this 063 I prefer this Delrin. Now when you're knocking these down, you want to make sure that the metal doesn't tip over on itself. So that one went pretty smooth. Get the next one. And this rubber coating protects the wood so it doesn't split. I've had these for years now and it doesn't split the regular construction lumber. This is EPDM rubber. You can get it at most roofing companies. I get it from Home Depot. And it also has the effect of not only protecting the shrinking facilitator's wood, but it also holds the panel. The panel locks in there really nicely. If you have a little bit of air underneath your gather, it'll actually shrink a little better. So there, what we did is we knocked down 4 gathers, and literally that would take minutes to do if you're not explaining the whole process. We take the flexible shape pattern, we'll put that on there, and we're almost there. We've only got less than an inch of rise in here. Now we can pound this out a little bit if we want. We can use the shrinking facilitator to help that too. So not only does it shrink, but it'll also stretch. That case, we don't use this end of the mallet. We'll use this dull end of the mallet here, the low crown. And as you hit it here, the shrinks will self-define themselves more, and we can get more shrinking out of here. You can watch that. You see how that edge gets ruffled up more so. So now you see that that's ready to capture those shrinks a little bit more. We turn the mallet around. And we get a little bit more. We're going to home this on a perimeter marks. We still got a little bit here. We'll give it another stretch a little bit right in the middle here. And you watch that edge. See how that edge, that's active live all the time, so you got to constantly watch that, because now you can gather those shrinks some more. And you got to make sure you don't walk over. So if they get pretty close to tipping over, then you put it up on the flat. And you can knock them down some more. Now this tells you everything you need to know. This needs to come up just a little bit still. We could shrink some more here or do some stretching there. So we'll do a little bit more stretching, which will actually induce more shrinking. As you're hitting the panel, it'll pop all over the place, so you just got to tell it, no, you don't want it that way, and you open it back up again. Now let's see what we got. Now this is what I call gross development of the shape. Now if we had a wood buck or a wire form buck or whatever type of buck we were using, the buck would not give us any information whatsoever. We brought this over to the buck would say, I don't understand your language. This understands the language. It knows exactly where the panel is at all times. What are we looking for? We're looking for filling this out 100%. We started out with almost 3 inches and now we've only got a little bit there. And we also want to make sure we don't go too far. Too far looks like this. If we go too far, this paper towel here will simulate. Say I make what I call a mushroom, a real high mountain. It'll cause this edge to lift off. So always watch your edges. These edges all touch all around, with the exception of right on this edge here, which has that reverse curve after first the shrinking is formed. So we got to go a little bit more. Now you can see how much that will distort. So we want to make sure we don't do the walkovers, so we'll carefully knock these down. So I'm sitting in a chair now. It's a lot more user-friendly. I don't have to bend over. I'm using the flat spot here. And I'm knocking these down carefully. If perchance you do get a tip over, what you have to do is I put them on the edge of the, I've got a flat stump over there, and I'll take and open them up with the edge of the flat stump. It's always important that you keep constant vigilant attention to that edge to make sure those don't go over on you. If they do go over and you can't get them undone, it will crack there. That's not the end of the world. You can just weld it up. Most of it's going to be trimmed off anyways here. A lot of my students will say, well, at this point I'm going to throw that in the trash. That doesn't look anything like an E-type nose panel. It means nothing what it looks like at this stage of the game. It's like saying when you're cooking, when you put all the ingredients in a bowl and you're mixing them up, and you're saying, well, that's not what it's supposed to look like when it goes on the plate to get ready to eat it. You always think in terms of what's it going to look like when it's finished. So this flexible shape pattern will read what needs to happen all the way through. So what you do is now you're doing close analysis of your surface here. Right here I've got some gap, and I look for where the most gap is. Right now it looks like right here is the most gap. So I'm going to hit that. That's going to cause more shrinking to happen automatically over here. So I'm getting shrink and stretch. And you'll have a ratio. That ratio can be anywhere, 50-50, 70-30, 60-40, in favor of both sides. Doesn't really matter. What matters is after you're done with the panel, you hit the panel and it's got good dent resistance. So we're going to open the panel up like that, which has no effect on the flexible shape pattern. And we're going to hit it some more. Every time we hit it, we change the arrangement. It tends to curl up on you. So you got to get into the habit of undoing that curl. And we want to hit pretty straight on. If we hit it to the edge, we're kind of punishing the metal, and it can cause a little stretch mark. All the marking we've made on this panel will totally come out or look like chrome plate after we put it in the English wheel. Now, as I teach in my class, this is one way to make a panel. It yields a beautiful result. You can also use a power hammer. They yield a beautiful result. You can use an English wheel with patent wielding, with no shrinking, just stretching. It'll yield a beautiful result. So how you do it is up to you. One way isn't necessarily better than the other. As long as the result is good, that's all that matters. Everybody says, well, what's the fastest way? Well, generally the nature of doing handmade automobiles, it's a slow procedure. It takes a lot of hours to hand build an automobile. You don't have robots working on it. It's all human labor. It can take 2,000, 3,000, 4,000 hours depending on what kind of car you're doing and what kind of level of complexity you're putting into it. For most people, this is a hobby. Nobody's going to ask you how many fish did you get when you went out fishing, which was your hobby, and boy, you could have gone to the supermarket and bought them cheaper. It's the whole experience. It's not just the end result. I would rather have a Ferrari than a fish, though, at the end. All right, so now we look for where it's popping the most, right here and here. So it tells me exactly my target. So I make a mental note of that. I go over there. It's trying to throw a shrink up here. I really don't want to do the shrink there, so I'll pound that one down. I could take it, but And it's a constant process of monitoring where you're at. You can't go too far ahead without monitoring. It would be the same as if you're running a manual mill or a lathe. You can only do 1 or 2 cuts before you start to measure. You've got to be constantly measuring. This is measuring. This is the blueprint. You can't deviate. Now there is a factor that working with sheet metal is very forgiving. So if I overshrink or overstretch, I can fix it. So it's not the end of the world situation or throw away the piece. But it's best to slowly creep up on your goals, constantly monitoring. Now I have an Italian Maglio. When I was doing the XK Jaguar pots, oftentimes I would do this all with the Italian Maglio. So I could do the shrinking and the stretching, and I could do a panel like this, which is nothing more than a mechanical arm, very simple power hammer, and I could power hammer this whole panel out probably in 10 minutes or so. That wouldn't be fully planished, that would be gross shaped. So now I'm down to like 1/4 of an inch, maybe 3/8 here. I want to leave myself a little bit of room. That gives me cleanup room. Now, after I planish this out, it will relax a little bit, and I'll probably have maybe in some spots as much as 1 inch of clearance between the flexible shape pattern and that. Between the panel and the flexible shape pattern. I can bring that all up with the wheel, or I can come over and lightly hit it again and bring some of it up by hitting it in the shrinking facilitator. Now I could use the beater bag to do the same thing, but generally when you're in the beater bag, you don't get the benefit of the increased shrinking that takes place. The shrinking facilitator kind of is like a mold or a hammer form, and it forms the metal and causes this to want to ruffle up some more, so you can capture all those ruffles. So not only are you stretching, but you're further shrinking. Now we're pretty close now. I think I'll probably stop at this point. But what I do next is I'll pre-planish, and I have a flat top stump for that. I'll bring the flat top stump over and we'll pre-planish this. Then we'll go into the wheel. We'll planish it all out. All right, here's my flat stumps. I use these for pre-planishing. I use the edge of them to open up a gather that's kind of went over it itself. I also use it for linear stretching right in here. At some point I'll show you how I use that little notch for linear stretching. It works really, really good. And we're just going to crunch this down a little bit. By crunching that down, we don't have as much problem going through the wheel to get that all planished out. There's a little bit of low spot right here, so that probably needs a little bit more popping. So I don't want to make the video too long. We've done the gross development. I've showed you the process of shrinking and stretching in a shrinking facilitator. And like I said, it usually takes just minutes to do it. And all this marking will come out like chrome plate. A little bit of wheeling. we locate this on, and I see over here it's a little deficient here, a little bit deficient here. Those have been plaguing us through the whole time. This needs about 1/4 of an inch. This is probably 3/8 or so right here. But I can put heavy wheel pressure on, and those are going to pop. We're going to wheel this, and we wheel this, it's going to relax it a little bit, so actually we'll lose some of the height that we've gained over here. So, but we'll make the determination if it's, you know, goes into like the half hour or 3/4 range to get this up fully planished, then we might stop and just pop these a little bit more in the shrinking facilitator, what I call elastic stretching. And that's a gross stretching. Not as refined as doing it in the English wheel, but it's a lot faster. So we will also, after wheeling it out and smoothing it, we'll probably trim it back so we don't have to work so much material. But that's going to be in part 4, the planishing out of it and trimming and getting the surface to close to where it needs to be. So for now, this is the end of part 3, shaping the E-type bonnet. All right, so that's the end of part 3. Please like, subscribe, and leave some comments, even questions. Wray, Schelin, Pro Shaper Sheet Metal. Thank you.